Hello and welcome to the channel. In this video, we will learn about pointers and arrays. To start with, let us first create a variable. Let's say a is equal to 20. Now, to print the variable, we can do printf %d. We'll put a \n here and then the name of the variable. We'll save it. We will compile the code and we will run. And the output gives 20, which is the value that the variable a holds. Now this variable is stored somewhere in the memory, and to see what that memory address is, we can simply append an ampersand before the name of the variable. And since memory address is not an integer, we will use %p to print out the memory address. We will just write it and we will recompile the code and we will run it. Now the string that we got in the output is the memory location where a is located. Now what pointer does is it stores this memory location and is said to be pointing at the variable a. To do that, let's create a pointer. It will have a data type. Since it is pointing to a variable of type integer, so the data type will be int, and we write here star, and let's say ptr. Now this pointer will hold the address of the variable a, that is the pointer will point to a. To do that, we can simply do ptr equal to ampersand of a. And now if we check this, we can simply replace this with ptr, and we will see that both the addresses are same. If a pointer is pointing to a variable, we can also get the value of that variable. To do that, we will simply dereference a pointer. To do that, we will just append a star here in the beginning and change this p to d. We will save it, recompile and run this, and it gives us the value where the pointer is pointing. Now let's solve a problem with this. Let me clear this first. Let's create two variables. Let's say integer a equal to 2 and integer b equal to 5. Now we wish to create a function swap which will receive two parameters and it will swap the values between them such that the value of a becomes 5 and the value of b becomes 2. We can also print the results. For that, we can write after swap a is equal to %d and b equal to %d. We'll put a \n here and we'll put a comma b. Now let's create a variable. Let's say void swap, and it will have two parameters, integer a, integer b. We will create a temporary variable temp which will hold the value of a. Now we will assign the value of b to a, and to b we will assign this temp value, that is the value of a. Now let's save the program and recompile and run it, and in the output we see that the values hasn't been changed, it remains the same. Through that, we come to know that a variable is always local to the function in which it is called. Since a and b were in the main function and the swap function didn't return anything, that's why the values didn't change. So to modify the values globally, we can use pointers. Let's declare two pointers, pa and pb. PA will hold the address of A and PB will hold the address of B. Now in place of variables we'll pass here their pointers, and we will make some changes to the function itself. Since we are passing pointers, we will say the pointers in the parameters, and inside the function we will dereference it. Now if we save and run this file, we see our desired results where the values have been swapped and a is equal to 5 and b is equal to 2. Also we can simply omit this part. Let's say I comment this one, and here in the function we can simply pass the address directly, and if we run this we will get the same results. Alright, let me clear this. Now let's say we want to hold a list of numbers. Let's say 5, 2, 7, 6. To do that we will need something called array, which will hold a list of numbers. Since the numbers are of type integer, we will write here int and the name of the array followed by the size of the array in square brackets, and we will write equal to and enclose these numbers in curly braces. To access these values we can use something called array indexing, where if we write a %d and inside this we can write the index. Now the index are the position of the numbers, but it starts from 0 instead of 1. So if we want to access the second element, we will write here 1. Let us save this and we will recompile and we'll run this, and we get the second element. Similarly, to get the third element we will change this to 2, and we will save this and we'll recompile and run this, and we get the third element. We can also get all the elements at once. Let's create a function for it. We will write a void and name our function get array, inside which we will pass an array and we will pass a length here. Inside the function what we can do is we can start a for loop. Let's say integer I equal to 0, I less than length, and then I plus plus, and here we can call printf %d, and we will give here a of I. We will write another printf here so that the cursor moves to next line, and we can delete this, and let's do another variable here. Let's say length, which is equal to 4, and we'll get and we will call our function get array, where the first variable is a and the second one is length. And if we save it, I'll just clear this part and recompile and run this, and it gives us the whole array. Now we can also see what happens if we exceed the size of the array. Let's say we want to print 7 elements, so we will do length plus 3. We will save this and we will recompile and run. Since the last 3 values were not declared, so they are the garbage values. Similarly, let's say we have here length equal to 3, and we will change this here, and if we write this, we compile it, it says that the array was initialized to have 3 elements, but we have given 4. So we can also try this. Let's say 6. We can change the size to 6, but instead we can only print the 4 elements. We will recompile and run. So what we find is we cannot exceed the number of elements given the size, but if the size is large we can still assign less number of elements there. Alright, we have printed the values of a by iterating using indexing, but let's see what the value of a actually is. Let's delete this and I will just type printf %d and we will print a. Let us save and we will recompile it. Now it says that a is a pointer, but we declared a to be an array. Since it is a pointer, let's check what the address is. To check the address, we'll replace the d by p and we will save it, and we will recompile and run this, and it gives us an address just like a pointer. Let's do one more thing. Let's create a pointer. Let's say p, and this pointer will point to the address of the first element of the array. Now let's try to print this value. If we save it, we will recompile and run this, we see that both the address values are same. So when we declare the array, what it does is it points to the first location of the list. We can iterate over this list also using pointers. Let's say we'll delete this one first, and what we can do is we can iterate using for I equal to 0, I less than length, I plus plus, and let's say printf %d. We'll put a space here and we can simply give here a, but we will dereference it. Since we want to increase this value, we will do plus I. We can do the same thing with the value p also. We'll just copy this, we'll paste this here, we will change this to p and we'll change here to p. We will just save it, we will recompile. Okay, I don't know why I changed this, but this should be d only. So control V, I'll replace it with d. We'll save this, we will clear the output, we can recompile and I can run the program. It shows us the array is similar. Alright, now every data structure should have some of the operations. In this case of array, we would expect it to have insertion, deletion and updating of elements. Let's say we want to delete the first element from the array. What we can do is, let's say we create a function. We will do a void here and we will write delete bname. We will pass the array here and we will pass the length. We can just start a loop. Let's say for I equal to 0, I less than length, I plus plus. Now let's come to the keyboard. Now let's say this is an array 0, 9, 4, 6 and these are their index 0, 1, 2, 3. Let me change this 0 to some other number, let's say 2. Now if we want to delete an element, we can simply put a of 0 equal to a of 1, and we can put a of 1 equal to a of 2. Similarly, if we go, we will generalize it to a of I equal to a of I plus 1. Alright, so to practice this, what we can do is we'll put here a of I equal to a of I plus 1. Now since we won't run the loop till the last element, we'll do here length minus 1. And let me clear this one first, and we can simply call our get array function here with our array a and length. And now we will call our delete beginning function. We'll say a and we'll do length here, but now length has been decreased, so we'll do length minus minus, and we will copy this, we can paste it here. Let's save and run this program. We'll compile it. Okay, it gives us an error. We'll go to line 16. We'll do an integer of I. We will save it. We will recompile and run the program, and we see that the first element has been removed. Now to delete from any index, we will follow a similar principle. Let's say void delete from any index. I will just name it delete. We'll put an integer and we will give the length of the array, and we will give the index from where we want to delete. So what we can do is, for integer I is equal to index I less than length minus 1, since the length has been decreased, and I plus plus. And what we can do is a of I is equal to a of I plus 1, and we will change this one. We have the length already here, and let's say we want to delete 7, but its index is 2. Let's run this and let's see what the output is, and we see that 7 is being deleted. Similarly, if we want to delete element from the end, we can write another function, void delete from the end. We'll say integer a and in length. But before writing this function, we can see it in a simpler way. Let's say we want to delete this element. We simply have to iterate array from this part to this part. So we can also omit writing this function. Let's say I will remove this and I want to delete something from the end. I can simply decrease the length and the value is deleted from the end. To update the element, we can simply write the function here. Let's say void update, and we will say integer a, integer value, integer length, and integer index. We can simply set a of index equal to value, and we don't need the length here, so we will remove this, and we can simply delete this part. We will call our update here for a, and the value, let's say 45 at index 3, which is the last element. We will save it, and we can recompile and run the code, and the last value has been updated. Now let's insert a value at the beginning of the array. Let's say we have the similar array here, and we want to insert a value at the beginning here. So what we can do is, we can simply shift the values first. We can start from the end and say a of four is equal to a of 3. A of 3 is equal to a of 2. A of 2 is equal to a of 1. A of 1 will be equal to a of 0, and a of 0 will be equal to new value. So if we generalize this, it becomes a of I plus 1 is equal to a of I, or since we have to run it backward, we can write it as a of I is equal to a of I minus 1, and at last we can set a of 0 is equal to new value. Let's implement this. We will do a void insert at the beginning, and we will say integer a, integer value, and integer index, and we would need length here. Now what we can do is, we can start a loop here for integer I is equal to length, and integer I is greater than 0, I minus minus, and we can set here a of I is equal to a of I minus 1, and outside this loop we can set a of 0 is equal to the value. Okay, since it is the beginning, we don't need the index here. We will delete this, and we will call the insert at the beginning function here. We will delete this, and let's say insert beginning. We'll pass here a, we'll pass here the value. Let's say we want to insert 34, and the length is len. Now since the length is increased, we will increase the length by 1, and we should get the right array. Let's save it. We'll recompile this. Okay, we have an error. We need a semicolon here. We'll save it. We will recompile and run this, and so we have 34 inserted in the beginning. To insert at the end, it is quite easy. We will do void insert end. We will say integer a integer value and integer length. We'll just say a of length is equal to value. And we will change this to and. Let's save it and recompile and run this, and here we have 34 inserted at the end. Now we can simply insert at a given index also. We can copy this function here and I will paste it here. I will change this to int and we will go until the value of index here. Let's say integer index, here we want to place. We will change this value to index and we will replace index equal to value. Let's try to run this. We'll do this one, and in place of index, let's say in place of index 2 we want to insert the value 34. Let's save it and we'll recompile and run the program. So here in the second index we get the value 34 inserted. In the upcoming videos we will learn more about data structures and constructing C programs along with them.